Hello students, welcome to my channel. Today we are going to learn about linear inequations. Linear inequations, well, this is a new concept for you, but don't be afraid. It is just like the linear equation chapter which we have already learned in the earlier classes. What is equation? Well, a linear equation is of the form ax plus b is equal to 0. So here, being an equation, we use an equal to sign in between. Like 2x plus 5 is equal to 0. So we solve it, we get x is equal to minus 5 by 2. Well, in linear inequation, we use the same thing, but we just replace an equal to sign with these signs, which are inequality signs. Which are inequality signs? Well, greater than or equal to, less than or equal to. So linear inequations are just like linear equations. We just replace an equal to sign with these inequality sign. So linear inequations are of the form ax plus b is greater than or equal to 0. It can be greater than or equal to, it can be less than or equal to, it can be greater than or it can be less than. So these are called inequalities. What they are called? Inequalities. So they are just like linear equation. As you can see, here it is ax plus b is equal to 0. We get only one value of x. But when we have ax plus b is greater than or equal to 0, we can have multiple values of x. That is why it is known as inequality. So, for example, we have 2x plus 5 is greater than or equal to 0. So when we solve it, we'll get the answer that x is greater than or equal to minus 5 by 2. So, what does that mean? This means that x can have the value which is greater than or equal to minus 5 by 2. Minus 5 by 2 is minus 2.5. So, x can have any value which is greater than minus 5 by 2. Similarly, 5 by minus 1 is less than 0. So, when we solve it, we'll get y is less than or less than 1 by 5. Y value is less than 1 by 5. So, this means that y can have any value which is less than 1 by 5. It can be 1 by 7, 1 by 8, it can be anything, 1 by 10. But it has to be less than 1 by 5. Similarly, if we have solved these two inequations I should say, then we'll get multiple values of the variable. So, when we solve a linear form of an equation with an inequality sign, it is known as linear inequations. What is called? Linear inequations. Okay. Next thing that we are going to learn is universal set. Now, replacement or universal set. What is replacement or universal set? Well, we have already learned in the earlier chapters, like you have learned in the chapter sets, which was there in 7th standard, 6th, 7th, 8th standard, that universal set, it is just like a solution set from which the numbers are derived from. Like, if I say that x is greater than, I say 5 by 2 or 2.5. So x can have any value which is greater than 5 by 2. But if I mention the set that x belongs to an integer, then the value of x won't be in decimal or in fraction. The value of x will be 3, 4, 5, 6, 7. So those integers which are greater than 2.5 will be the solution set for x. So that's why they are called replacement set or universal set. Replacement or universal sets are those sets from which the value of x can be derived, and it has to satisfy the inequation which we have solved. So that is why it is called replacement set or universal set. So for your reference, I can tell you that we have many universal set, like we have a replacement set called n, which are called natural numbers. Natural numbers basically mean that the value of x will start from 1, 2, 3, 4 and it will go up to infinity. Then we have whole numbers. Another universal set can be a whole number which starts basically from 0 and it goes up to infinity. Both natural numbers and whole numbers do not contain any decimal, it do not contain any fraction. Okay, so neither they contain any negative sign like -1, -2, -3. They are not the solution for the natural numbers or whole numbers. Then we have z, which is integers. Integers, they start from -infinity, they come to -2, -1, then 0, 1, 2, and they go up to infinity. So again, integers are all the digits which include natural number, which include whole number, and also the negative integers. Okay, but integers also do not include any negative sign, any whole number. Integers do not include, they include whole numbers, they include natural numbers, they include negative sign, but they do not include any fraction, they do not include any decimal sign. Then after that we have rational numbers. Rational numbers. So rational numbers are of the form p upon q, means they are in the form of fraction where q can never be equal to 0. Q can never be equal to 0. By this we mean that a denominator can never be equal to 0. We have already learned that 0 cannot come in denominator. It can come in the numerator, but it cannot come in denominator. And then we have R, which includes real numbers. We have real numbers. Real numbers will have real number, it means we have all the rational and irrational numbers. All the numbers combined together, it forms real number. They form real number. We are not going to be using them much in depth, but yes, while solving these digits, these signs N, W, Z, Q, R, they are of very much importance, because we'll be plotting them, these inequations on a numbered line, we'll be using these signs. Okay, so there, by that time you need to be careful that if N is written, that means it is natural number. If W, capital W is written, it means it's a whole number, which is 0, 1, 2, 3, 4 up to infinity. If Z is written, it is an integer. If Q is written, it is a rational number, which is the form P upon Q. And if R is written, it is a real number. Okay, so let us move ahead and now discuss the inequalities postulate. Inequality postulates. If you see in your book, chapter 4, on the first page, we have been given inequality postulates. So what are those? I'll just discuss with you. So it will be recommended if you take your book and take out your page number 4/1. So the first inequality postulate: adding to or subtracting from both sides of an inequality by the same number produces an equivalent inequality. What does this mean? Suppose, see, if A is greater than B, we have been given if A is greater than B. Now, if I add 5 to both these sides, that A plus 5 will be greater than B plus 5. Okay? You can even check, like if I can say 7 is greater than 3. Yes or no? Then if I add 5 on both these sides, if I add same number on both these sides, then the equality remains the same. Then 12 is greater than 8. So if I add same digit, add, or even if I subtract same digit on both these sides, the inequality does not change. I give you one more example, like if A is less than or equal to B. Now if I subtract the same digit from both these sides, like suppose if I subtract 3 from both these sides, then also the inequality won't change. That means if A minus C will be less than or equal to B minus C. For example, if we take the same inequality, 7 and we have 3, or I can write, suppose inequality, if I take less than, or 3 is less than 5. If I subtract 4 from both the sides, so 3 minus 4, then it will be again, if you see, if I subtract the same digit from both the sides, then again minus 1 is less than 1. So inequality does not change after, even if I add or subtract the same digit on both the sides. Okay. So this is my first postulate, that adding or subtracting same digit on both the sides does not change the inequality. Next, second inequality. The second postulate that we have is if we multiply and divide a positive number on both the sides of an inequality, then the inequality does not change. Like if A is greater than B, then if I multiply x on both the sides, then inequality does not change. It will remain as it is. Okay, but the condition is the positive number should be there. We need to multiply positive number on both the sides. Like if you see, we take the same inequality, we have 7 is greater than 3, and if you multiply 2 on both the sides, then the resulting answer you can see 14 is also greater than 6. Same way, if you divide the same digit on both the sides, positive digit on both the sides, then also the inequality does not change. Like if we have A is greater than B, then A divided by X will be greater than B divided by X. Okay, like if we have 12 and is greater than 6, then if we divide 2 from both the sides, then you can see the answer that the resulting answer will also have the same inequality sign, that is 6 is greater than 3. Okay, so now we'll multiply the third postulate. We'll discuss the third postulate. Well, in the third postulate, if we multiply or divide a negative sign, then the inequality gets reversed. Inequality gets reversed. Like if you have A is greater than B, and if I multiply by a negative number on both the sides, then the resulting answer, the inequality sign will get changed. That minus AX is less than equal to minus BX. Let us take one example. Like suppose we have 7 is greater than 3, and if I multiply minus 2 on both the sides, so after the multiplication you can see that minus 14 is less than minus 6. So if we multiply or divide negative signs on both the sides, then the inequality sign gets changed. Inequality sign gets changed. This is a very important property, that on multiplying or dividing a negative number on both the sides, the inequality sign gets changed. This is a very important property because many students forget to change the sign and thereby they commit a mistake. So we have to be very much particular on noting it down that whenever we have a minus sign on both these, whenever we multiply or divide by a negative integer on both these sides, the inequality sign gets changed. One more thing, my friends, like fourth thing, that we have an habit of, if there is like in equations we have, if it is minus A is equal to minus B, we cut minus sign on both the sides, we write A is equal to B. Yes or no? But in inequality, if we cut minus signs on both the sides, then the sign of inequality gets changed. Like if you just take an example over here, if we had minus 14 which was less than minus 6, yes or no? If we cut minus sign on both the sides, then the sign of inequality will get changed. Then 14 is greater than 6. Okay, if minus 14 is less than minus 6, if we cut minus signs on both the sides, then after cutting it, the sign of inequality will get changed. Then 14 will be greater than 6. So learn to change the inequality sign if you multiply or divide by a negative integer, or even if you cut minus signs on both these sides. Last postulate. After that, I will discuss the exercise in my next video. The next postulate that we have is fourth postulate. What it says? Squaring both the sides of an inequality produces equivalent inequality if both sides are positive. That means if A is greater than B, okay, it is given A and B, and if I square both the sides, squaring both sides, okay, then A square will be greater than B square. When this will happen, when A and B are both positive integers. But if A and B are both negative integers, that if A is less than B and then if I square both these sides, squaring both these sides, then a square will be greater than b square. When this will happen when a and b are both negative. This will happen when a and b both are positive. Let us take an example, like if we have 5 is greater than 3, yes or no my friends, then on squaring both these sides, 5 square which is equal to 25 and 3 square is equal to 9. So 25 is greater than 9. Yes or no my friends? But if a is less than b, suppose if minus 5 is less than minus 3 and I square both these sides, squaring both sides, then what we'll get, minus 5 square will be 25 because square is always positive, it is never negative, and minus 3 square will be equal to 9. So what we'll see here, that 25 is greater than 9, or I can say minus 5 square is greater than minus 3 square. So if a is greater than b and if we square both these sides, then a square will be greater than b square, no doubt about it. But if a is less than b, when a and b both are negative and we square both these sides, then when we square both these sides, the sign of inequality will get changed. Then a square will be greater than b square. With this, I'll just end this video and we'll continue in the next lecture. Thank you.